In this chapter, let's discuss the properties of solids. Before the discussion of solids, let's first classify the states of matters with large number of atoms or molecules, according to the distances and interaction between the constituent particles. There are a few different states of matters, but the most important states are gas, liquid, solid and plasma. Gases are composed of atoms or molecules, which can move almost freely in the space. The mean distance between particles in gas is much larger than the sizes of the particles. Therefore, the interactions between particles in gases are very weak. A gas has no defined volume. The volume of the gas is the volume of its container. Plasma is similar to gas, except that the particles in plasma are charged, such as electrons and ions. Liquids and solids are both condensed matters. The constituent particles in the condensed matters can be atoms, molecules, and ions. The distances between the particles in liquid and solids are about the size of the particles themselves, and cannot change significantly. So, condensed matters have relatively defined volumes. Due to the short distance between the particles in condensed matters, their interactions are strong. The main macroscopic difference between liquid and solid is that liquids are free to distort while the solids are resistant to the change of shapes. We can use liquid water and ice to show the microscopic difference in liquid and solid states. First, the molecular interaction between the water molecules in liquid water and ice are the same, that is, hydrogen bonds. In ice, neighboring water molecules have definite relative positions and orientations to minimize the energy. For example, the HOHOH structure in ice is fixed. Though the atoms can vibrate around their equilibrium positions, they cannot move to a further place. In liquid water, neighboring molecules don't have definite relative positions and orientations. They have enough energy to rotate and translate. However, the distances between molecules are retained. Solids can be categorized into two types. A crystal is a solid, in which particles are arranged in repeating patterns in spaces much larger than the size of the patterns. We say, crystal has long-range regularity. For example, solid sodium chloride forms crystal. The repeating pattern is a cube with sodium cations and a chlorine anions. This pattern repeats itself numerous times in all directions. In contrast, an amorphous matter only has short-range regularity. For example, in amorphous carbon, each carbon atom is either sp2 hybridized to bond 3 other carbon atoms like in graphite, or sp3 hybridized to bond 4 other carbon atoms like in diamond. It is a kind of regularity. However, the structures of each carbon atoms are random. Neighboring carbon atoms can have different structures. So, the regularity is short. Liquid crystal is a special state of matter. Molecules can move in the liquid crystal. Thus, like liquids, liquid crystals do not have defined shapes. However, like in crystals, molecules in liquid crystals form repeated patterns. Typical liquid crystals are made of long rod-shaped organic molecules. You can see an example here. In liquid crystals, molecules are aligned in the same direction to minimize the energy. It leads to anisotropic properties of the liquid crystals. For example, conjugated hydrocarbons are conductive in the direction of the long axis of molecules. Light polarized in this direction is heavily absorbed. Light polarized in the direction perpendicular to it is weakly absorbed. Thus, such liquid crystals are polarizers. The orientation of molecules in a liquid crystal can be controlled by external electric field or the material in contact with them. Thus, the direction of polarizer can be controlled. The anisotropic light absorption of liquid crystals is the basis of a liquid crystal display. The detailed mechanism of LCD is beyond the scope of general chemistry. If you are interested in it, you can find it from other references. Based on the knowledge about liquid crystals, it is not hard to understand.